Okay. So, all right, I think we have to start here. Okay, so title this Notes, Evaluating Limits Analytically. Part 2. Ha ha ha. The sequel. The limits strike back. Okay. So I think. Goodness. Let me see. Okay. So just as like a little bit of, just like a bit of a refresher here, we'll jump into just making sure we remember how to do this stuff. So we can find each limit. So we're just going to run into an example first. Okay, just kind of finish up some of the stuff we talked about from yesterday. So, okay, first thing, the limit as x approaches 2, 2x squared minus 3x plus 1. Okay. And so again, first thing we should always try whenever we go to evaluate a limit is what? What's be our first tool we go to? Direct substitution. So we just plug in that 2. Okay? So let's see here. It'll be 2 times 2 squared minus 3 times 2 plus 1. And let's see here. 2 squared is 4 times 2 is 8. 8 minus 6 is 2 plus 1. We should get 3. Okay? I can kind of convince myself there's nothing else we don't have to worry about, thinking about like kind of like that square root of x example that Tyler was asking about before. We don't have to worry about that because this function is continuous everywhere, right? It goes from negative infinity to infinity, continuous everywhere, so we don't have to worry about any sort of like problem issues. This is just, what is this thing, by the way? What is it? Just what does graph be? A parabola, right? Quadratic equations, or quadratic functions. So it's just a parabola, so there's, there's nothing funky in there, no discontinuities, no holes. It's just that. And so plug in a 3, we should be safe. Direct substitution works there. No problem. Okay? Let's try another one here. One more, and then we'll get into a theorem. The limit is x approaches 1 of x squared plus x plus 2 over x plus 1. So again, the limit is x approaches 1 of x squared plus x plus 2 over x plus 1. Okay? So again, the first tool, the first thing we should always try when we go to evaluate a limit, okay, is what? Direct substitution. So plug it in. So let's see here. It's going to be 1 squared is 1 plus 1 plus 2 over 1 plus 1. So 4 over 2, 2. Okay. Okay. Now, what are the other tools that we have right now to evaluate limits? Besides direct substitution, what are the other methods that we had to evaluate those limits? Graphing and a table, right? So, if I were to graph this right here, actually I'm going to use the table instead because the graph's kind of hard to see sometimes, but I think the table is easy. So if I were to graph it, or put this in the table, and I recommend everyone give this a shot. I know it seems kind of silly, Mr. Whitmire, we already found the answer. Why should I care about looking at this in my table? Well, just to make sure that you can use your table accurately for these kind of strange problems, okay? So please do take the time right now, pull that calculator out, type in your function, and let's go to our table. Okay, just to make sure you can do it. All right, if you feel like you already, have an idea about what x values you want to plug in, go ahead and start plugging those x values to convince yourself that the limit as x approaches 1 is 2. Okay. And I will do the same. So let's see here. Okay, question, Anna. Yep. Right, and again, Anna, this is the stuff, though, that we hit now when you can ask that question, as opposed to in the middle of the test, you're like, I have problems, and now I can't fix these. Okay, this is why we do this, okay? Get you the practice. Yeah, Emma. So, like radians or degrees, you mean? So we're not dealing with any trig, so you're safe either way, but in general, though, Emma, we do want to make sure we're in radian mode, okay? Oh, let's go to your y equals then. Let me take a look. It's not x minus 1, it's x plus 1. But again, this is why we do this, okay? This is why we do this, to make sure we get a good practice typing things in and taking care of that correctly, okay? We make the mistakes now when it's just little mistakes, not on the test when it hurts our grade, okay? All right, so very clearly here, we approach 2, right? It's very clear. All right. Now I'm gonna go out, not on a limb here, but I'm gonna say, like, we really don't need to, like, kind of build up into the 1 and build up in from both sides. If you want, you can just put in, like, you can put in, like, 0.99999 right here, and you can do, like, 1.00001 right there, just so that way, you know that you're getting from both sides there. Okay, now notice something that my calculator does is kind of funny here. In the table it says 1, but when I highlight it, it still says the 0.999999, okay? So be careful about that. The calculator, I guess because just rounding or whatever, it just says 1, but it does actually count as the 0.999999. If you go over to the y, it says 2, but actually the correct value is 1.9999995, okay? Now granted, again, we know it's going to be close enough to 2, but the calculator rounds it, okay? So just be aware of that. If you want to see what the actual value is, you've got to highlight the actual number. Now here, when we plug in 1, it actually gives us 2 because, again, we can use direct substitution here. But you want to check to make sure the left-hand side and the right-hand side agree, and they both are approaching 2. So we're good there, okay? Because, again, like we saw in Tyler's problem, the value of the function worked, but then the left-hand side did not exist. So you want both the left hand and the right hand to approach the same value. Okay? Have I beaten that dead horse long enough? I'll judge by your glazed faces that the answer is yes, and you're ready to move on. All right, theorem. Here we go. Okay, so there's no title for this theorem, so it's not that important to have a title, but it's got some useful information in it. Okay, so functions that agree at all but one point. Okay, that's like I guess that is kind of the title, but it's not. Yeah, it's like that's kind of like it's like functions. It's about this theorem is about functions that agree at all but one point. Okay, and I'll kind of show that after we do this more mathematical definition here. So let's see. Be a real number. And let f of x equal g of x for all x not equal to c. Okay, so let's kind of break this down here real quick, because I know some of you guys, we start writing in math language, and you're like, I am completely lost, this makes no sense to me. Okay, so c is a real number. Okay, and we're just going to come up with 2 random functions, f and g. They're equal at every point except what? At c. Except at c, right? They are equal to each other for all x that are not equal to c, and c is just a single number. So basically these functions, you might say that they are equal at all but 1 point, which is thus the title, right? Okay, it's like the titular line right there, okay? So, in an open interval, I'm sorry, this is not an end of a sentence, it's continuing. So, question?
So, just so I can, like, visualize it on a graph, could it be just, like, a line on a graph and then, say, c is the x value of 5. At 5, there would be, like, 2 different points off of the line.
Say that one more time, sorry, I'm having trouble picturing it.
No, never mind. I'll see it when we get more.
I'll give you a visual real quick. You saw, like, in one of the homeworks, the one we talked about, number 20, I think, where it had the parabola but had a hole in it.
Yeah.
That is, and then if you were imagine doing the same exact parabola, but the parabola with the hole filled in, That is
So it'd be
a
like-
function that agrees at all but one point.
Okay.
They're
so
the
it'd
same
be-
parabolas except for that one little point.
And that point would be filled in.
Yes,
It would
exactly
be-
right. Exactly. One would have it filled in, one would not.
Okay.
That's the
And
agreeing
the
at all but
point,
one
and
point.
there would be another point somewhere else. on that.
Sometimes, sometimes not. Sometimes that other point down there is not there. It's just like the parabola with a hole missing, and then the other parabola is completely filled in.
Okay.
All right. In an open interval containing C, that is the end of a sentence. If the limit of g of x exists as x approaches C, then the limit of f of x also exists, and the limit as x approaches C of f is equal to the limit as x approaches C of g. Okay, so again, what does this mean? F and g are almost the same exact function. G, I guess in this case, we'll say, maybe it's f though, it could be either one, just pick one. Let's say g. G, though, is missing, has got a hole, 1 point missing from it that f does not have missing, okay? The limit, and that's at the value x equals c. Okay, so at the value c, g does not exist, like a hole there, f does, okay? The limit, though, as our x values approach c of g, must be the same as the limit of f of x as well as x approaches c. So the limits will still be equal because it's just a hole that's missing. So you'll still have something coming down, something coming up. It's just a hole that's missing. So the limits will still exist. The function value at that point may not exist, will not exist for one of them because they differ at that point. But the function value, the limit value should exist. Okay, so let me show you how that kind of shows up here, and we're going to use that to kind of go into another method for evaluating a limit. Okay, these are like advanced limit evaluation techniques. Okay. So really, the original method we have is direct substitution. You always try direct substitution first. Don't forget you also have the table on your calculator. Should you have, this question asked on a graphing calculator section of a test or a quiz, you may absolutely use your calculator to determine that limit or to check that you did your limit correctly by just using your table. Okay, so don't forget that table is a tool available to you. All right, anyway, so example, let's say we want to find the limit as x approaches 2 of x squared plus x minus 6 over x minus 2. All right. Now, we teachers do a good job of kind of handicapping you guys a little bit. All right. This is not like real life right now, right? Because what have I done to you? I've already told you we're going to use a different technique or method here, okay, to solve this problem. So right away I've already kind of made this problem easier for you, because if you were to come across this problem in the wild, you wouldn't necessarily know that, oh, I'm going to have to use cancellation technique here, because that's what the directions say. The directions won't say that. The directions will just say evaluate this limit, and you'll have to come up with the idea that you're using your different strategies. Okay? So let's try and do this as you guys. I expect you guys to kind of try and tackle a problem like this. So the first thing I want you to do is to tackle this using what?
Direct substitution.
Direct substitution. Brandon, do you have a question?
Well, I guess that kind of like what you were about to do.
Okay. So, well, what's your question though, just in case?
You can't use the direct substitution, so this is why we use the cancellation method.
Exactly. But let's go ahead and try the direct substitution here. So we're going to plug in the 2, right? We're just going to plug it in. So I get 2 squared plus 2 minus 6 over 2 minus 2. And right away, we see we're going to have an issue. The denominator is going to be what?
0.
Yeah, 0. Okay, and what's the numerator going to be?
0.
A 0 as well. Okay, now, this is good news, though, because when you get a 0 over 0 like this, that means that something in the numerator will probably cancel out with something in the denominator, a 0 over 0. If you get like a 5 over 0, then you're kind of stuck, because that probably means there's not something that will cancel out. But when you get 0 over 0 like that, that means there's something in common up there, and it will cancel out. Okay? So this is you in the wild right now doing this problem. You've gotten to this point, and you say to yourself, oh crap, I get 0 over 0, this is not something I can end with. Now I need to go back to the problem and see, can I try cancellation? And that means we need to factor. That's exactly right. So here we go. Let's see, x plus 3, x minus 2. Okay, and now you're in the middle of the problem, and you're like, it does factor, and what can we do at this point now that we factored it? Cancel. Okay, so we're left with x plus 3. Now, you'll notice here that I put an equal sign from here to here. Okay, this is equal, and that is truly equal. Remember in the past when we were talking about like canceling out things with functions, and if you just have the function x plus 3 times x minus 2 over x minus 2 like that, and then normally in like your other math classes you'd be shown, okay, those cancel out and this is equal to x plus 3. These two things as functions, are they exactly the same? No. Because does this right one exist at x equals 2?
No.
Does the right one exist at x equals 2? Yeah, it does, right? I can plug in 2. 2 plus 3 is 5, no problem. Does the left one exist at x equals 2? No. These two functions are not the same function, okay, at 2. But everywhere else, guess what? They're the same. Okay? So these two things are equal everywhere else except for x equals 2. Okay? So these are two functions that agree at all but one point. So technically these are not equal unless I put like a little comma over here and put like x not equal to 2. Okay? Then we can say those are equal. However, their limits, what I just set up in here, their limits will be equal. Even though we're approaching that problem 2 value, we're approaching it, we are not equaling it. So as long as we're just approaching the 2, it's okay, the values will still be the same. So this is a true statement. I don't have to put a little argument saying x not equal to 2, x is not going to equal 2, we're just approaching the 2. Okay, we are approaching it. That's what a limit does. We just approach it. We don't get to it, we approach it. So these things will be equal. Okay? So now what can I do? Now we can direct substitute. And the limit is 5. And the limit is 5. Okay. Questions on any of that? Questions on any of that? No questions? Alrighty then. I want you guys to try one here. The limit as x approaches 1 of x cubed minus 1. Yes, I'm giving you a difference of cubes. Okay. So try that one.
I feel like that, right?
It's like putty to figure out
Okay. Let's go to Tyler. What'd you come up with? 3? 3. That's correct. Did you try direct substitution first? See, you're already like, Mr. Whitmire.
But then I realized it was.
Okay, cool. Yeah, as long as you can see that, and you don't even actually, this one you don't even really need to plug in. You just like mental math that, and it's like 0 over 0, right? Okay, so that works. And again, don't forget, if you want to convince yourself you're right, if you have your calculator, graphing calculator available, that means, in your homework, you can certainly check this as well. You can like literally just type the function in, go to your table, okay, and then we're going to approach, let's see, 1, so I'm going to go like 0.999 and then 1.001, and sure enough, it looks like from both sides we're approaching 3 there. Okay? So you can use that calculator to help you check, and I recommend you do. Okay, question? So if you got 3 over 0, so that would indicate kind of like an undefined there. What I would then recommend you do is go to your graphing calculator to convince yourself that like, okay, something's going on here, let's see what's happening, okay? And then, evaluate from there. Check the left-hand limit, check the right-hand limit, and chances are they're not going to agree, and so the limit probably will not exist then, if that's the case. Probably. But again, check it, okay? Alrighty, so there's that. Moving on, we're just going to go to the next technique. Okay. Method 2. So again, should direct substitution fail, another technique we want to be able to use is rationalization. Sorry, I have to say it like that so I can spell it correctly. Rationalization technique. Okay? It's about to get messy. Alright, so here we go. Hope you got plenty of space. Good. Alright, we're going to find the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. Okay. Okay.
What's it called?
Conjugate. Okay, so first thing we should try here is not rationalization, right? Mr. Whitmire again is kind of like handicapping you a little bit because in the wild I won't tell you to rationalize this thing, okay? But what's the first thing we should try here? Direct substitution. But we
look at that and I know it's
right.
not
You're going to get 0 in the denominator. 0 plus 1 is 1. Square root of 1 is 1. Minus 1 is 0. You get 0 over 0. No bueno. We're moving on. Okay, we find something different. Okay. Could we factor this?
No. Not really. No.
Yeah. No. Nope. I mean, you maybe could factor it, but no. Okay. So rationalization. How do we rationalize something?
Multiply by the conjugate.
Yeah, we got to multiply by the conjugate. If those of you that don't remember what conjugate is, that's where you take the square rooty thing, and instead of minus 1, you're going to multiply by plus 1. Okay? Why do we do this? Because I hate you. Yeah, so how is this thing going to work? Well, if you look here, let me go, maybe I'll just do it right up in here. Okay, when you see like A minus B times A plus B, do you remember what that thing's called? All right, what does this end up becoming when I FOIL it out?
A squared minus B.
A squared,
B squared.
so it's like A squared minus BA, but plus AB plus B squared, right? And then what happens to that middle term, those middle terms? They cancel. And so you're left with just A squared, minus B squared. Sorry, it should be a plus, it should be a minus B squared. A squared minus B squared. You guys remember what this is called? Difference of squares, exactly right. So what we're trying to do here is to set up a difference of squares. Now, why is that going to be helpful? Well, if I go from here to here, what's going to happen? I'm going to be squaring a square root, which is exactly what we want because it'll cancel out that square root. I'm going to square the negative 1, and then my middle terms will cancel out. So I'll be left with undoing that square root, essentially, and then having to square the 1, which is no big deal. So that kind of helps simplify things. Okay, so let's do this, though, longhand, so we can kind of see it being done. Okay, so I'm going to do this one longhand, and the next one I'm not going to do longhand. So we're going to FOIL this. Okay, it's like a binomial times a binomial. So you've got to FOIL it. So Root x plus 1 times root x plus 1 is what? Just x plus 1. Oh, don't forget to continue to write the limit here too, okay? Mr. Widmeyer almost made a no-no there. Okay, and again, for those of you guys, there's a handful of you that I wrote on your tests that, continue, writing the theta through, continue writing the limit through. Do not drop the limit until you've actually direct substituted, okay? I know it's a lot of writing. I know your little hands are going to get tired, but you must build up the strength in your hand, okay? I will make your hand strong, so you will do the work, okay? So anyway, first, outer. So 1, positive 1 times root x plus 1. So it's 1 root x plus 1. And then minus 1 times root x plus 1. Minus 1 root x plus 1. And then the last. Negative 1 times positive 1. Negative 1. All over. Do not distribute this out, I recommend. Just leave it. X times the quantity, root x plus 1, plus 1. Do not distribute it out. Okay? Why, Mr. Widmeyer? Well, because things might simplify, and if you have it distributed out, you're going to have to refactor it again to cancel things out. So leave it unfactored, leave it unmultiplied. Okay? Leave it.
Let it
Okay. Let it go. That's right. All right. So things cancel here, right? What cancels out in my numerator? The 1 root x plus 1 and the minus 1 root x plus 1. The plus 1 and the minus 1. And when I get that down to there, I have an x over x times the square root of x plus 1 plus 1. What else cancels? The x's. What? Okay, and that will happen in general, okay? You'll have some nice cancellations because of that rationalization. Okay? Be very careful about your cancellations. Don't try and skip, especially since you guys are just starting out, don't try and skip too many steps at once to cancel these things out. Okay? You need to make sure that you're taking your time with this. Take care of the addition subtraction first, then rewrite it, and then cancel things out. I know it's a lot to rewrite, but it's important to get it right over you having a hand that's not tired, okay? Again, we'll make your hand strong. Okay, question, Emma.
Wait, will the square roots and the cancel out?
Yes, yes. And again, why? Because we set it up to be that way. We're basically always doing a difference of squares, so the middle term should cancel out like that. Okay, last step here, what do we got to do? Now we can direct substitute. And now I can drop the limit because I'm direct substituting. So I get square root of 0 plus 1, square root, so 0 plus 1 is 1, square root of 1 is 1. So I get 1 over 1 plus 1, which is 1/2. We did it.
Nice. We did it.
All right, and we can check our answers in our graphing calculators here. So square root of x plus 1 minus 1 divided by x. Go to my table. No. Go to my table. Delete things out. I want to go approach 0 from the left from the right. So I'll do like negative 0.0001 and 0.0001. And sure enough, look at that. From the left from the right, 1/2. Okay? All right. Now I'm going to have you guys try one. Oh, Mr. Witt. All right, here we go. Limit as x approaches 2 of x minus 2 over 3 minus the square root of x plus 7. Okay? Convince yourself that 2 does not work by direct substitution first before you go into the rationalization. You might be wondering, but Mr. Widmeyer, why? We already know it's in the rationalization section. Why do I need to check? Well, because you want to practice good habits, right? The first habit you should have when you see a limit like this is direct substitution. Because sometimes you can just direct substitute and it works. Even if there's a square root in there, sometimes it still works. So check that first. Okay. So give it a shot. I'm going to do it here real quick too. I will tell you, you can show as much or as little work as you want, okay? But my recommendation is show as much as you can. And yes, I do tend to save the harder ones for you guys to do on your own. And then remember, once you get your answer, what you think is the answer, you can use your calculator to check to see if you got it right. So really, you don't even need to know, you don't even need to ask me if you got it right. You can check using your calculator. Okay. If you're stuck, I will come around and assist.
Grab me as I'm walking around. Get stuck on anything. Raise your hand too. I'll come around and help.
Yeah. Okay.
Troubles.
Yeah.
So there should be parentheses around that x plus 7.
Yeah.
So go ahead and do the simplification.
Nothing cancels.
Well, you didn't. You could. I would simplify this. Do the subtraction there, the denominator.
Oh, that's
And then
yeah,
you will
the
see.
negative. Yeah. I see.
Okay. Great. So 9 minus x plus 7, right? So you can distribute it, and then combine like terms in the denominator. Okay.
Question back. I do. I like to leave it like you have the right there. Exactly. I would not multiply that out. See what happens here. Yeah. So you did first, you did the outer, then inner, and then the last should have left with a minus root x plus 7. Root x plus 7 times root x plus 7.
How would you get it?
That was the last thing.
6? Not negative. I got negative 6.
No, that's okay. What you have right there, it's 9. No, that's right, 9. And then you had everything else here was right. You just want to add on to the end.
It's so good. It's so close. Just remember.
And then you have minus. It's root x plus 7 times root x plus 7, which is the quantity x plus 7. Minus the
Yeah. Really with that. Negative x plus 2.
Oh, what is?
You got that negative 1.
Are you like doing your side work? Like what is this right here? You're just multiplying out. Okay, I got you. So yeah, root x, it's a negative root x plus 7 times a positive root x plus 7. So it becomes just negative x plus 7. That's 1x. You see that? Take minus half. Exactly. Because you multiply something by itself, it squares it, right? So
Is this?
parentheses.
No.
Yep. So those cancel, and then you can do 9 take away.
Yeah, you
Minus x minus 7, right? You have to distribute the minus sign there. What's the matter, Caleb?
Long night, Caleb.
Party too hard last night, Caleb.
Hard kills me. Just
Played CSGO for too long.
No, I'm laying.
He couldn't go to sleep. So, stuck on something, or he's kind of zoned out a little bit, or?
It's super late.
minus the quantity.
You got this? Yeah. No.
Y'all doing okay back here? Yes.
I kind of get how you.
Minus the quantity. Okay, so go back to the
Plug in,
But then it'll be like,
so then it would become a negative x,
I think it equals 6.
and then a plus a 2, and then you factor negative out.
You get negative 6.
So yeah, minus x, no, there's a minus x, 9, minus 7, plus 2. But you factor negative 1 out of the denominator, this becomes negative x minus 10. And then it becomes just like over like negative 1. And then, but yeah, it becomes negative 6. Yeah, your final answer is negative 6. It's like it's negative the entire quantity. Like it's like negative that. If you want to like ignore that negative 1 thing. Yes, that is correct. Yes. Yes. Okay. Question, Max? Not quite. The 2, there should be nothing, it should be 1 in the denominator, because the x minus 2 cancels out with x plus the x minus 2 there. The 2 it just cancels, you're left with just that in the numerator. So it's there, so it will be just negative 6. So, not quite, you want to simplify your denominator, right? Okay. All right. In the interest of time here, we're gonna kind of press on, but I think for the most part, y'all handle this pretty well. Okay. So let me just kind of. So first of all, the answer is negative 6. Very good. Okay. So Mr. Whitmire gave you a very tricky one here, right? Okay, with those negatives being a little sneaky, Mr. Whitmire. Okay. So there it is. All right. So things I want to highlight. Okay. Everyone did a great job right here. Multiply by the conjugate, good. And I'll get to your question in 1 second. Then when we multiply the conjugate there, everyone did a pretty good job right here. This thing I want to be careful with. The minus here, okay, it's minus the quantity x plus 7. So be careful. Make sure you put parentheses in there. It's minus that quantity, so you want to make sure that minus is going to get distributed there. Okay, and again, don't multiply that numerator in this case. Okay, simplify the denominator though, it's 2 minus x. Well, doggone it, that is pretty close to x minus 2, but it's not the same, is it? No, but if I factor a negative 1 either out of this or out of this, doesn't really matter which one. I factor a negative 1 out of this one. It becomes x minus 2 becomes negative 2 minus x, which is the same thing as that. I cancel. The negative comes down still. Then we direct substitute. It becomes negative 6. It's your final answer. Negative 6. Okay, and a question?
Are we able to use your calculator in the test?
There will be calculator sections and non-calculator sections. So on the calculator section, absolutely. On the non-calculator, no.
Is there a test
Would this probably be on the non-calculator? Yes. Non-calculator.
Don't do it.
But here's the thing, like the good news is, I'm telling you right now, you will probably see one like this on the test. And right now you are thinking, I'm going to fail this test.
Is there a
But we
test
have
date
time
yet?
to figure it out and get it down, okay?
Is there a test date yet? Is there?
For the next, retest date?
No, not retest, like the test.
No, I don't have a test date yet, no. It won't be next week, I can almost guarantee. So.
Okay.
Okay, we have one more technique. One more technique we should be able to do. Additional. I don't have a name for this other one, but.
Does it involve adding?
Yes.
That's all math at this point, but.
Okay. I know you guys really like fractions.
Fractions
T.
are my favorite thing.
Yep, and I'd write my t's with a curly tail like that, so that way they don't look like plus signs.
I'm just gonna do an X.
What? Next name from what? From what?
Good.
Calculus is giving her a pain in the neck.
Yeah. You could. Honestly, probably the best thing would be the way.
Okay, so we can say it one more time.
Because I need to lay my head down, so it's wrong.
Doctor's orders. I mean, Ryan. I can't argue with that.
What? Yes, I remember that.
Okay, so you might wonder though, Mr. Whitmire, when I'm in the wild and I'm doing these problems, okay, I can understand that like we want to try direct substitution first, right? And if direct substitution fails, how am I supposed to know that I should do cancellation? How am I supposed to know that I should do rationalization? How am I supposed to know that I'm going to do something different here? Well, when you see this, right, what do you see? You see polynomials. And what's one of the main things we do with a polynomial but factor? So like that kind of clues you in here. If it gets 0 over 0, chances are I probably need to factor. Okay? Likewise, with rationalization, do you ever really rationalize something that doesn't have a square root in it? If it doesn't have a square root, then chances are you're not going to rationalize. So here, the square root kind of clues us in. Maybe I need to rationalize. Okay? Again, always try that direct substitution first. But here, if that doesn't work, then rationalization is the way to go. So, following that kind of like flow of logic then, when we see fractions, and specifically fractions within fractions, what do you think we need to do?
Well, maybe we should try direct substitution first.
Oh, we should try direct substitution first. Let's see here. So plug in 3. 1 over 4 minus 1 over 4 is 0 in the numerator. That's okay.
Yeah, 'cause that's 3.
3 minus 3, 0 in the denominator. 0 over 0. So no. What should we do here though? When we see fractions, what do we want to do? So we want to kind of combine our fractions here. Getting like a fraction within a fraction like this, we want to get these fractions together and try and get like common denominators and make it look, kind of nicer than this. A fraction within a fraction is not very simplified, so we want to fix that. So let's take care of our numerator here first. Okay? To subtract fractions, what do you need to do? Common denominator. So what is this denominator here missing? The 1 over t plus 1, what is it missing?
T.
From these two fractions here, to put them together.
Oh.
Missing a 4, right? So I'm going to multiply this fraction. Maybe I'll put it in red, so that way it highlights and stands out. So I'm going to multiply this one by 4 over 4. What about the 1/4? What is its denominator missing? A t plus 1. Okay, so 4 times 1 is 4 over, and I'm not going to multiply together the denominators.
I tried to read T.
Don't multiply together the denominators. Minus, right, there's a minus between them. And then this one's going to be t plus 1 in the numerator over 4 times t plus 1.
Are we going to get rid of the bottom?
And we're going to leave the bottom there too. We'll take care of that eventually. If you made it like 1 over t minus 3, or I don't know, we'll see. Yeah, we'll take care of it eventually though. You still need to rewrite it though because it's still there. Okay, so Mr. Whitmire, this looks worse than before. This looks worse. Okay, well sometimes it has to get worse before it can get better. Okay, so this is the case. All right, so now that we have a common denominator, what can we do with these two fractions? Subtract them, put them together. Okay, let's do that. All right, so okay. Well, I'm going to go ahead and rewrite the t minus 3. I'm going to go ahead and put the 4 times t plus 1 in there. What's my new numerator going to be, though? So 4 minus t plus 1 like that?
No.
Very good. It's minus the quantity t plus 1. Okay, this subtraction, it's subtracting this entire numerator. It's subtracting the quantity t plus 1. Okay, and we saw this yesterday, you remember? So,
God, if only we could change that minus to a multiply.
So minus t minus 1, this in the numerator here is going to become 3 minus t in the numerator. Right? I did the 4 minus the 1, and then I just left the minus t. Over 4 times t plus 1, all over t minus 3. Okay. Woo. A little bit better, but it's still got a fraction within a fraction. Okay? Anna, do you remember what are we supposed to do at this point? Switch the, sorry, which one are you talking about? The T. Okay, take this and multiply by what? -1? Okay, so you want to factor out -1, so I'm going to kind of like go woo down here. Okay, so T3, so we'll make that negative T minus 3 then. Okay, we factor the -1 out, so it flips the order around there. Over 4 times T plus 1. But Anna, I was talking more about how do we fix this fraction within a fraction? What can we do instead? Remember what we did yesterday? Exactly. Dividing by something. Dividing by something is the same thing as multiplying by the reciprocal. So dividing by T minus 3 here is the same as multiplying times 1 over T minus 3, like so. Whoa, Mr. Whitmire, things cancel. That's right. Okay, that's right. Things cancel. Okay, things do cancel. So the T minus 3's, and Anna set it up very nicely for us to go ahead and just cancel that with the negatives like that. Okay, and so we end up with the limit as T approaches 3 of -1 over 4 times T plus 1. Okay. Almost. Almost.
One more?
What's the last step?
I don't know.
So direct substitute.
Direct substitute. Now we can't. So basically, you're in all these three methods, you're looking to try and cancel something out. Like you first try direct substitution, it doesn't work. Then you use one of the techniques. Either you factor and cancel, you rationalize and cancel, or you get a common denominator and cancel. And then once you've canceled, you try the direct substitution again, and sure enough, it works. Well, there you go. That's right. You always have the calculator. Unfortunately, on the test, there'll be a non-calculator section, and this could show up on that. Right? In fact, most likely will, because did we need a calculator at any point in here? Nope. Just your brains. Okay? But again, this is the expectation, guys, right here. Okay? We can do this. We don't have to be able to do it right now, 100%, but we can do this 100%. Each one of us here is definitely capable of doing this. Okay? You can absolutely do it. All right, I have one more I want to look at. Last one.
I like it.
All right, so I see, sir. Blah, 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 blah. Given f of x equals 3x squared minus 1, find the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x.
I hate delta x. It's such a
Different x.
It's a difference quotient. Now, if you don't like the delta x, you can, on the side here, if you want to, you can put let delta x equal h or c or whatever variable you want to use instead of the delta x. That's fine. You must indicate that when you're doing your work for a test or something like that. If you just magically change the variable without putting this like little sentence or like little statement, let delta x equal h, then I'll be like, where'd this variable come from? I don't know, you're making things up. And then it'll be a big X, and you get a 0. Okay? So you need to put this in somewhere to indicate that you're changing the variable. Why do I do that? Not to be cruel to you, but to mimic what the AP testers will do. I know who you are. I know what you mean. They will not. Yeah, Anna.
So why can't you just write H?
Because the problem, I wanted to put delta x there. And it'll make more sense why we use the delta x later when we talk about the definition of the derivative. The delta x really is standing for a small change in x, the variable x. But for right now, we're just going to leave it as some arbitrary, weird way to write things. I can remember being in your seat and having that delta x there and being like, I don't understand. But, it was...
Makes more sense.
Okay. We have to evaluate this limit using this function. This is complicated, right? As judging by some of the way you guys did on this on the last test with the question like this is difficult for us, right? Okay, so we need to be careful here. All right, we're evaluating this limit. So this is the thing we want to evaluate. All right, I got to figure out what f of x plus delta x is. So I'm going to go ahead and do that kind of side work over here. So I'm going to figure out what is f of x plus delta x. What does that look like? Well, here's f of x. It's 3x squared minus 1. So what will f of x plus delta x be? It's going to be 3 parentheses in place of the x plus delta x. Squared, don't forget the minus 1. Okay? So I did that as, that's like a little bit of a side work. But my main work I'm going to now start. The limit as delta x approaches 0 then. Instead of writing f of x plus delta x, I'm going to use my actual function here. I'm going to use this piece that I just wrote. 3 parentheses x plus delta x quantity squared minus 1. So I just plug that in. Okay? Minus f. And you better put parentheses around that function. Okay, or else you're going to get it wrong. All over delta x. Okay, so there's the setup. There's f of x plus delta x. There's f of x. Oops, and I meant to go. Okay. Yes, Anna.
When you're like doing the work, could you, instead of putting delta x, could you just write an h?
I mean, again, if you say this, if you say this little statement, and you can change all your delta x's to h's, and you're good to go. You can just continue on from there. Yep. Okay? So, now we simplify. Okay, so we still have the 3. To multiply x plus delta x times x plus delta x, that is going to be a, we have to FOIL that, right? We have to FOIL this. So it becomes, I think, x squared plus 2x delta x plus delta x squared. Okay, don't forget the minus 1. Just kind of just FOIL it out. X plus delta x times x plus delta x minus 1. So like that's where I am. I'm from right there to right here. Okay, minus the quantity, so it'll be minus 3x squared plus 1. We distribute that minus sign. Okay. All over delta x. It's all over, that's right. Alright, I distribute this 3. So much writing. But again, this is the discipline that we build up to enable us to be successful on assessments and things. Okay? Minus 1, minus 3x squared, plus 1. All over delta x. Whoops, sorry, I went off the screen. Okay? Now, everything's multiplied out, all the minuses are distributed, everything's ready to be combined like terms. Are there any like terms in my numerator here?
Minus 1 and plus 1.
So, minus 1 and plus 1? Anything else? 3x squared and the minus 3x squared. This should happen. Everything that doesn't have a delta x term should cancel out in the numerator. Okay? When you're doing these, don't just magic them away. They actually need to cancel, but I mean, use that to confirm that you got it right if your non-delta x terms cancel out. Okay, beautiful. 6x delta x plus 3 delta x squared all over delta x.
And then factor out.
I was going to say, at this point, these are not like terms, right? This has an x and a delta x. This one has delta x squared. So we can't combine these. It looks like we could maybe, this delta x here could cancel, but we got to factor out the delta x, right? We don't want to individually cancel these things out because we have addition between these two things. But if we factor out a delta x from the numerator there, we have delta x times what's going to be left inside the parentheses here? 6x plus 3. You also could have factored out a 3 if you wanted to there. Oh, oops, I forgot a delta x with the 3. There we go, perfect. Fits. Okay, that's supposed to be a little delta x in there with the 3i. Okay, the delta x's cancel. And so I have the limit as delta x approaches 0 of 6x plus 3 delta x. Whew. Final step. What do we do? Direct substitute, 0 goes in for the delta x here, so it's 6x plus 3 times 0, and oh my gosh, we did all that work just to get 6x at the end. Oh my gosh. Alright. Don't worry though, I'll show you guys a shortcut after we take the limits test, okay? So, I'll show you a shortcut after we take the limits test.
I'm just gonna Google the shortcut.
You can do that. You could ask your ABBC friends. Yeah.
Can I come to Flex and you show me Flex?
Nope. I'll wait till afterwards, okay? So anyway, there's your final answer. Questions on any of that?
No.
All right, so.
No homework for the weekend, right?
Ha ha ha! Sure, no homework for the weekend, but on Monday, homework.
Monday you have homework. See what I did there?
That's so
See what I did there?
Wait a minute.
No homework on the weekend.
Wait a minute. I'm gonna do it Tuesday morning.
Why don't we have school on Monday?
Monday, frost down. Oh
Ah.
Love those Jews. Thank you, Dad, Caleb.
Are you
No, email and said
shalom.
Yeah. Stapler is back on my desk, I think.
So, I was completely unaware of the thing. So just, I heard rumors.